Good morning, everybody. And a couple of important things. Let's get to if you look at Blackboard, you'll see I have an announcement that you should have gotten from in your email. I'll be giving test number 1 on Thursday online. What that means is on Wednesday sometime I'll post in the assignments test number 1. I'll have with it a periodic table, which I'll show you in a second. Later today, I'll put that in the lecture part of Blackboard so you can look at it before the test. I'll also have instructions how to take the test and upload a PDF file. If you look in yours over here, you should see a new area called PDF instructions. In there, I have how to do PDF files from cell phone or just in general, how to take a test or lab, and how to upload it to the assignment area. Test number 1 has 7 pages, and one of those pages is important information, which I will post later today in the lecture part of Blackboard. And that's certain formulas I'm not going to ask you to memorize, but you do know should know how to use it. We'll have 27 problems. I'm not big on multiple choice, but once in a while I'll pop a few on. I've never given a test my own that's all multiple choice because I historically hate multiple choice tests like that. But anyways, you will have 7 multiple choice. The others are just short answers or workout problems. If you have done, there'll also be a periodic table for you to download, and I'll show you that in a little while. On Wednesday, I'll do my world famous review for the next test, test number 1. Because this is an online course, and I'll explain in a second about that, why I'm doing this, we'll have our regular Zoom meeting, which I'll go over our lab that you'll be doing on Thursday. Don't forget, tomorrow we'll have a lab. I'll be posting that soon after our class, sometime by 4 p.m. on Blackboard for you to download tomorrow's lab. But don't forget the lab you did last week, lab number 1, densities, is due tomorrow. And I'll ask you to upload it, as always, to the assignment area. If you go to PDF instructions, that tells you how to do that if you're not familiar. Now, the one thing I'll be doing differently for online tests as opposed to if we were in a classroom, I'll send out the PDF file I'll have on Blackboard will be password protected. Thursday morning about 8:45, I'll send out the password for that PDF file so you can open it. All right, because some of you, your schedules and everything, and technically this is supposed to be an asynchronous course, I will give you until Friday morning to finish test number 1 and upload your answers to the assignment area Blackboard. However, I should tell you, realistically, if you're in a classroom, test number 1 should take about 40 minutes to do. And my tests, if you were in a classroom where you have 50, 55 minutes, they're never more than 40, 45 minutes, unless you haven't studied and done the practice problems, then they're a lot longer. Because you will be taking the test at home and I'm not using the schools or online, you can't cheat stuff. And a lot of that is not practical because what happens if your internet goes down connection or other things, I don't like using that, I don't. I have, Dr. White can be sneaky, I have put some things in the test to show to me if you're cheating or not. Couple things. 1, you should not be looking at your notes for this test. 2, You should not be going on the internet. You shouldn't be talking to or emailing other students. And you should take about an hour to do the test. You need a little more time, hour and a half. That's okay. But you shouldn't cheat. I will do what's in my syllabus if I catch you cheating. And trust me, I'm good at that. Hopefully I don't catch anybody cheating because you're not. So please don't. Waiting for my tea to cool down. All right. Next thing I want to do quickly, and if you're not sure how to do it, I'll go over it in my office hour tonight. Uh-oh, that ain't gonna work. Hang in there. Yep, that works now, hopefully. All right, you have a calculator like this or similar. The first thing you should know is how to put it in scientific notation. Now for this one, above this button, you'll see SCI/engineer. And what you do is push the blue button because it's the top key, second key, and hit that, and you'll see three things there. Flow, SCI, SCI and engineering. Use this key. It's hard to do things. To bring it over to engineering, hit enter, and you'll see down here, you have a calculator, scientific. Now, how do you put a scientific number in here? Well, you put the first part number, say it's 4.5. I'll learn how to do this one of these days. There, 4.5. Now, to put the scientific notation, 10 to the whatever, you're going to look and find on there, there's a key here, and above there it says double E. And on most calculators, double E. This one is the top above this button, so you have to hit the double key, the second key, and then double E, and you'll notice I put an E on there. And then if it's a positive number, you'll put in like 5. And then I'll put times 2.3. Then I want 10 to the third. Blue key, double E, 3. And I'll hit enter. And you notice, if you can see it, I don't know how bad this is. You'll have a number here, and then you'll see very small X10, and then on here you'll see 09. And that's how you do scientific notation. Now there's an important thing. If your number is 10 to the minus 2, after you hit the double E, you don't use this key. This key is for subtraction. On all calculators, this one's here, you'll see bracket minus close bracket. This is the key you use when you want to use a minus, like -3, 10 to the minus 3. So you do your number, blue key, double E, then minus key, this one, and then 3 over here. And that's how you do it. If you're not sure how to do your calculator, see me tonight in my office hours. There's about any calculator that has been made I can figure out, especially since the manual's on the internet and we can download it. So you should practice today and tomorrow or the next day how to use your calculator, because you'll need it for test number 1, 2, 3, 4, 5, and the final. So it's a good thing to do. By the way, did you notice I went to a new barber? Did a good job too. Me. It's the first time I've given myself my own haircut, and I didn't cut off my ears, but it turned out pretty good. I got a real sharp barber scissors from Amazon. All right. Let me ask a quick question because I'm still sometimes not doing this right. Everybody see the word ions on their screen? Yep, thank you. Let me just move my tablet down to where I can use it. In a classroom, I wouldn't have to do all this, but we're not in a classroom. All right. All right, we're all ready to go. All right, I was talking in chapter 4 about metalloids, which you can skip. We talked about in the periodic table what are metals, what elements are metals. And you should know, I was thinking about this over the weekend, that a metal, this is something you should know, has luster, has thermal conductivity, electrical conductivity, and it's malleable. Luster means you can shine it up to make it nice and pretty. Malleability, you can pound on it and make it super thin. Thermal conductivity, it transmits heat. And electrical conductivity, it transmits electricity. And you should know some examples of metals: aluminum, copper. I have gold, silver. I don't have down there lead, tin, and zinc are all metals. Metalloids are non-metal. I'm not going to ever ask this on a test, but it doesn't have luster. It doesn't have thermal conductivity or electrical conductivity, and sure isn't malleable. You have carbon like in coal, you can't shine it up, even though a diamond you can. But anyways, and then there are things called metalloids. I'm turning the switch off. Will this ever be on a test? But they have some of the properties of both metals and non-metals, and they're very important. The most important one is silicon, which is, and there are others too, that make semiconductors, which make transistors, which make the boards for things like your cell phone or my monitor computer. All right, switch is still off because I'll talk about this later on, what's in the chapter, so I feel I should go over it real quick. When an atom loses or gains electrons, it forms an ion. I'll talk more about this later for test number 2 material. And types of ions, cations, anions. Again, I'm going through quickly. This won't be on test 1, be on test 2. Cation is when a element loses electrons and has less electrons than protons, has a positive charge. An anion has a negative charge, and that's when an element gains electrons, so it has more electrons than protons. Not on here, isotopes. I'm never going to ask it, but I'll use the term. Isotopes are atoms that have the element that have different number of neutrons. When we get into nuclear chemistry, this plays an important role. Nuclear symbol I've never used, so I'm going to skip this. Atomic mass number of an atom, that's the sum of protons and neutrons in the nucleus. You don't have to know this, but in real life, you have different isotopes, and therefore the atomic mass, which I will also call the atomic weight, is a mass average of the different isotope weights. And what that really means is, here's the periodic table you'll be using for test 1. Notice it doesn't have the names on there. You should be learning those. Tea time break. But anyways, if you look at the periodic table here, the number underneath is called the atomic mass, or I'll call it atomic weight, AT.WT. And we'll learn later on for test number 2.
Hi, Professor. I'm sorry. We can't see. We're not seeing the.
Oh, I know what I did wrong. Hold on. Thank you for telling me that. Can you see it now? Okay, no complaints, so I'll continue on. Zoom's pretty good, but it's got some things I forget to do. All right, now here's the periodic table. You'll be doing it. The number underneath, like for carbon, 12.011 is the atomic weight of carbon. And oxygen, 15.999, round that off to three significant figures, 16.0. And we'll talk more about this for test 3. All right, now, last night I was reviewing what I did and I was writing the test for Thursday, finishing it up, and I realized, guess what? I forgot to talk about something important. So let's talk about something important, but since I messed up a couple minutes ago, can everybody see a blank page now? Okay. One of the things I haven't talked about, and I thought I had a slide, but I might have jumped by it, is chemical formulas. That should be M and then U. But anyways, I'm still learning how to write on a tablet. Now, a lot of you know this right here, and that's a chemical formula. That's sodium chloride. Hold on 1 second. And Neil, I'll have to call you back in an hour and a half. I'm teaching. Bye. That was quick. Sorry about that. And sodium chloride is the chemical formula. And what this means is there's one sodium, one chlorine. Now, if I ask how many atoms are in sodium chloride, the answer is 2. Now, for water, the chemical formula, and a lot of you know this, but it's good review, is H2O. And how many atoms are in water? 2 hydrogen. This is the chemical symbol. This number to the right of the chemical symbol tells you how many elements there are of that element, or how many atoms of that element are in the molecule water. 2 hydrogen. When there's only one, we don't put a number. 1 oxygen. How many atoms in water? And the answer is 3. Now, sometimes, and we'll learn more about this for chapter 2, or test number 2, elements have what's called complex ions, polyatomic ions. And this would be an example. It's called magnesium hydroxide. Now notice here, I have a bracket, and to the right of bracket, there's a number. And what that tells you is that inside the bracket, there's 1 oxygen, but in the molecule, it's 1 times 2. Therefore, how many atoms are in this molecule? Magnesium oxide, 1 magnesium. How many oxygen? Well, there's 1 here, but you multiply it by 2. So the answer would be 2 oxygen. And notice there's 1 hydrogen here, but it's inside the bracket, and the number outside the bracket, lowercase to the right, is 2. So that means there's 2 hydrogens. And if I do my math correctly, there are 5 atoms in magnesium hydroxide. All right, it's your turn. Let's have some fun. See, Dr. White shares the fun. Why don't you try this one first? How many atoms are in KBr? Don't just put the answer in chat. Give everybody time to do it. I appreciate you doing that, but I still want to give everybody. All right, and time's up. Let's take a look. We have one potassium. Remember, Br is one element, bromine. So there's one of them. If I did my math correctly, is two. And I assume everybody can see what I'm doing now because nobody's saying anything over the audio. Let's do another one. That's an A here, Ca. How many atoms are in that molecule? Remember, don't put it in chat. Let everybody have a chance to do it. I'll give you 4.87 seconds more. 1, I got a slow clock. 2, 3, 4, 4.2, 4.5, 4.6. Time's up. All right, we have one calcium, and then this is a chlorine. Notice subscript 2, so that means there are 2 of them, and that means there are 3, and that's your answer, atoms and calcium chloride. By the way, calcium chloride, you can buy during the winter from any big box store or home improvement store. It's called calcium chloride, and those are the little white pellets you throw on your sidewalk to melt the ice. And I'll talk more about how that does that later. Oh, let's do another one. That's an Mg. How many atoms are in, it's called magnesium nitrate, and I don't know if this exists or not. Don't put your answer in the chat. Give everybody time to do it. All right, let's take a look at this. And the question is, how many atoms are in this molecule? Well, there's one magnesium. Oh, we've got a bracket. And you look to the right, lowercase, and the number 2. So however many atoms inside, you multiply by 2. And this has 1 times 2 is 2 nitrogen. Oh, look, there are 2 oxygen here in the bracket. So for this one, you multiply 2 times 2, that's 4. And if I add this right, that would be 3 plus 4 is 7. Don't forget, Dr. White does the German 7, because I think it looks, oh, let's do one more. These are fun. This is sodium sulfate. How many atoms? And don't put it in the chat. Give everybody time to do it. I know you want to, and I appreciate you, but how many atoms are in Na2SO4? All right, time's up. Let's take a look at this. Notice to the right, subscript. I think I said superscript before. It's really subscript. There's a 2, so there's 2 sodium. There's 1 sulfur. Oh, an oxygen, and subscript to the right, 4. I'll get it right yet. and add it up, and once again, you get 7. And that's the skill you should know. By the way, while we're here, sodium sulfate, Na2SO4. Have you ever bought something like electronics or optical goods or certain other things, and you see a little packet in there and it says on there, do not eat? And what that is sodium sulfate. Sodium sulfate is what we call a desiccant. That's something that absorbs water. And I'll teach you later on how it absorbs water, but it keeps water from damaging whatever you're buying until you open it up and you get it. And that's Na2SO4. See, chemistry is everywhere. All right, as of now, I have finished everything on chapter 4 and everything that will be on test 1. I was going to do it today, but I'm going to hold off till tomorrow. Tomorrow, I will be going through the problem set for chapter 4. 1, 2, 3, I got it right. And look out, it's once again Bad Humor Monday, and I'll do that. All right, now, because it's summer and we're moving along at a fast pace, especially since I'm not doing full lectures, even if I was in the summer, I'm going to get ahead lecture-wise. I'm going to start on chapter 9. Chapter 9 and chapter 5 and stuff afterward will be on test 2, but I got to get going and work on that. So let's go to chapter 9. And first of all, any questions so far on anything? Remember, in my class, Zoom or anywhere else in my life, there's no such thing as a dumb question. Wow, I did a great job in my own haircut. All right, quick. Does everybody see chapter 9 up there? Excellent. Thank you to all. I'll have to name you my thumbs up people. Thank you. All right, this is for test number 2. Now, the next couple of pages, I'm going to turn the switch. Will this be on a test? Click to the off position, but this is good background information to understand when I turn the switch back on. Right now, it's in the off position, which means this won't be on the test. All right, we've talked about electrons, protons, and neutrons being the 3 subatomic particles that make up an atom. And all elements are made up of atoms. Atom is the smallest particle of an element that has all the properties of it. Well, I showed you that the nucleus contains the protons and neutrons, and it's in the center, and it's very dense. Where are the electrons? Well, they're all around the nucleus in the center of an atom, but where are they? Are they like planets, like in our solar system? And the answer is no. Where are they? Well, that's what you're going to learn about in this chapter. Now, in order to discuss this again, switches off, we have to talk about electromagnetic radiation. That's energy that travels through waves through space. It has wavelength and frequency. And this is a thing you don't have to know. This is new, C over lambda. Oh, I should tell you this, though I can't pass it up. I went to Technical Institute for my undergraduate degree, IIT, Illinois Institute of Technology. And a favorite thing was somebody would say, what's new? And the answer would be C over lambda, ha, ha, ha. Anyways, now, the electromagnetic spectrum is an arrangement of various magnetic energy in decreasing order. Let's see, hold on one second. If I were in the classroom, I'd be doing the same thing. Nope, don't want to do that. All right. Can everybody see, and someone do it over audio? Can you see this electromagnetic spectrum with the different colors?
Yes.
Okay, thank you. All right, now, if you look at these through different, like this one over here that's large, different types of energy have different wavelengths, and also they call it frequency. And if you notice right over here, you have the different colors of visible light. For those who remember high school, I still do, Roy G. Biv, how to remember different colors of the spectrum of the rainbow. Well, these are different energy levels. And things like radio waves have a certain energy and certain frequency. And as you go higher up, you have higher energy electromagnetic rays. The most powerful are gamma rays. And unfortunately, in our universe, gamma rays will not turn you into the Hulk, if you know that. But anyways, that's the electromagnetic spectrum. And there are different packets of energy of light or other energy. And I showed you that, different ones. And visible light and UV light are all electromagnetic. So are radio waves, microwave, like cook your food, and X-rays the doctor uses. Now, it turns out, back in the late 1800s, chemists found out that if you heated an element very hot in a dark room, it would give off light of a specific color. And time to go to the internet again. My thumbs up, people. Can you see the screen with pretty picture? Thank you. All right, if you look over here, different elements give off different wavelengths of light. And you can separate these into their different colors by what we call a prism. Here, a prism certainly heat up something, gives off light, and you can get different bands. This is for helium. You can only see almost nothing. Iron has a lot of lines, colors. And this is called atomic spectra. And this taught chemists something very important. That when you look at that, what's causing the spectrum? And that's different packets of energy. Switch is still off. A great chemist, Bohr, I believe German, came up with a theory that electrons travel around the nucleus at fixed distances. He was sort of right. Again, switch is off right now. And that each orbit is called a quantum number, a certain energy level, like steps in a ladder. And energy level between each orbit is fixed and called the quantum energy. Again, switches off, and electrons can go from higher steps in the step ladder or orbits or quantum energy to lower ones. When it goes from higher to lower, it gives off energy in the form of light, which is why you have atomic spectra, and each element has a unique spectra because they have unique elements. Now, how does this play in a role? Well, and we'll do a lab on this in about a week from today or tomorrow. Fireworks work by heating up elements, and when they cool down, they give off light, different colors. Have you ever seen a really nice fireworks display? That's due to the electrons being heated, going to a higher level, and then coming down and giving off light. Now, If you haven't figured it out, I think I might have told you, Dr. White's favorite color is red. Right above my desk here, here's one of my favorite things. I like red things. And if you don't believe me, here's another one. Now, in fireworks, what element, and I didn't ask you to learn the atomic symbol for this, but what element gives off red? And that's strontium. And that's because there are different levels where the electrons are, orbits, or we'll learn another name in a second. And these energy levels have what's called quantum numbers, but I'll give you another name. And that other name is called shells. Now, again, the nucleus, very dense, positive charge. Why? Because it's got the protons. Neutrons have no charge. And around the nucleus is where the electrons are, and we call that the electron cloud. Why? Because it's a very large volume, very low density, just like clouds are in the sky. Now, what do I mean by low density? Well, if you had a nucleus the size of a baseball, then the diameter of the atom would be 2.5 miles. Let me show you that. If I had a nucleus of an atom here, the whole atom would be 1.5 miles that way, 1.5 miles that way, and that's where the electrons are. And there's a lot of open space, just like a cloud. Again, this material is on test 2. Now, click, the switch is on. This will be on a test. These are things you should know. This will be for test 2, but I've got to move ahead. Now, where are the electrons? The electrons are in what we call electron shells. And I won't ask the definition, but you should understand what a shell is. That's the region of space around a nucleus that contains electrons that have approximately the same energy and spend most of their time approximately the same distance from the nucleus center of the atom. Now, each electron shell has subshells, and these are regions of space in which an electron within an electron shell that contains electrons that have the same identical energy and are essentially the same distance from the nucleus. Shell has subshells. Now, for this, I'm turning the switch off. We also have what's called orbitals. And that's where you're going to find an electron. If you could stop all motion when the electrons are moving. This gets a little complex, but switches back on. I will put this in important information, but shells have a very, very difficult name. The first shell is called shell 1. By the way, Dr. White's smiling. First shell is shell 1. Second shell is shell 2. Third shell is shell 3, and fourth shell is called 4. Now, there's something you should know how to understand. I'll explain more about it. I will give you this chart for test number 2. Now, in shell 1, this gets real complex. How many subshells? 1. In shell 2, how many subshells? 2. Shell 3, 3, and 4, 4. Now, a subshell is named by, I'll go over this in a second, by the shell number and something else. What's that something else? Well, it turns out they call it in the book orbital designation, but this is really subshells. Oh. Subshells have the letters S, P, D, and F. Now, S is the lowest energy subshell. F is the highest energy. For those of you who aren't familiar with this symbol, this is less than. That means S has less energy than P, than D, than F. This is lowest energy. This is highest energy. Now, I'll never ask on a test, but students have asked me over the years, what does S, P, D, and F stand for? For some reason, back in the early 1900s, when this was being developed, chemists decided based on spectroscopy that certain elements, certain electrons had very sharp, then they called other lines in the spectra principal, diffuse, and fundamental. How they came up with those names, I don't know. And guess what? I don't really care. But they are used. Now, the subshells and on the test, this is what's in your book, but I'll change this. Subshells can only contain a certain amount of electrons. And you do not have to memorize this because this chart I will give for test number 2 and important information, but subshell 2 can only have 2 electrons, P, 6, D, 10, F, 14. So the maximum number of electrons in any subshell S, whether it's 1s, 2s, I'll explain what I mean by that in a little while, can have 2, P can have 6, D 10, F 14. Now, this page, I'm going to turn it off. I just want to cover it quickly. Orbitals are in the shells, and they can only hold 2 electrons. Electrons spin, and they can spin clockwise or counterclockwise. And because of that, they have a magnetic field, switches off. Therefore, you always put opposite spins, either up or down arrows, when you're showing what's called the orbital diagram. Good news, I'm not going to put that on the test because most students get it wrong anyways. But again, switches off. S orbital is circular. P orbital looks like an hourglass. If I were to stop time, electrons in the P orbital would either be in this area or this area. And P orbitals play an important role in our daily life. Like, how many of you have heard of sister trans fats? That trans fats are bad for you and cis fats are good for you. And that's because of P orbitals between 2 carbon atoms. That you'll learn more if you take my organic chemistry, which we won't get into. Now, when you're showing where the electrons are, and don't memorize this chart, but I just want to go over it. Electron subshells are filled in the order increasing energy. You always start the lowest one. And this has got a name called the Aufbau principle. And electrons occupy orbitals in a subshell such that each orbital acquires 1 before any other orbital acquires the second. We won't go into this. This is also called the bus seat rule. And why bus seat? Because when you go onto a bus, you'll probably take the empty seat before you sit next to someone you don't know. And finally, no more than 2 electrons can be in an orbital, and they must have opposite spins. This is called the Pauli exclusion principle. Luckily, this stuff I won't go over. But now, hint, switches on. Electron configuration. Electron configuration is a statement how many electrons an atom has in its subshells. Now, I will never ask, what is the electron configuration? But I will ask you to know how to draw it. And let's look at an example. Yep, wrong thing. So the first question would be, or first one, draw the electron configuration for lithium. And the first thing you have to do is find out how many electrons there are in lithium. And if we know lithium, first of all, chemical symbol is Li. The atomic number tells you how many protons and electrons, and therefore you have 3. So now we know we have 3 electrons in lithium. And how do you do the electron configuration? Now, the first shell is 1, and the first subshell is S, and we call that 1s. And if you look at the table, which I don't want to jump back and forth, normally on the board I'd have this written, I probably will after the break. You'll have how many electrons can you put in any s orbital? And the answer is 2. And you put that subscript. 1 has 1 subshell, and that's S, so it's full. And then you go to the next shell, which is 2, and the first subshell is S. And here you can have 1 electron. And let's take a break now. I'll see you in 5 minutes at 9:56. Everybody come back at 9:56, give or take a half minute, and I'm going to go stretch. So I'll see you in a little while. All right, everybody back? Let me get you back. You know I have to use that at least once a lecture. Maybe, maybe not. All right, let's go back and look at this because let me do it another one because you need to know how to do that. Now, if you look here, I have the two charts which on tests will not be handwritten. Here we have shell, their names 1, 2, 3, 4. How many subshells each one has? One has one subshell, shell 2, 2, 3, 3, 4, 4. Now, subshells is S, P, D, and F. S, and you'll be given this on test 2, has 2 electrons. You can put in max P6, D10, F16. Now, let's do the same thing, electron configuration of carbon. And the first thing you have to find out is how many electrons, because that's what we're talking about, does carbon have? And you go to your periodic table and you see carbon has an atomic number of 6. So we now know carbon has, get back. Six electrons. Now, what's the starting point? You always start the lowest energy shell, 1. Remember, going from 1 to 4, you go from low to high energy. I won't put this part on the test that you have to remember, but the first shell is 1. And what's the first subshell in 1? You always start lowest energy, that be S. We call the subshell for that both a number and a letter. So we have here 1s. How many electrons can we put in any s orbital? And the answer is 2 max. So I'm going to do that by showing superscript 2. Now, have I done all the electrons? No, I need 6. I only done 2. How many subshells does 1 have? 1. And you can only put 2 electrons in 1s. We filled it up. So now we have to go to the next lowest energy shell, which is 2. And what's the first subshell in 2? And the answer is 2s. How many electrons can I put in any s orbital? 2. So I'm going to put that in there. So now I have 2 plus 2 is 4. I've got to get to 6. How many electrons maximum can you put in any s orbital? 2. Well, I filled up 2s, and now how many subshells does orbital 2 have? And the answer is 2. The first one is 2s, and the next one is 2p. Now, how many electrons maximum can I put into p? 6. How many do I have to go? 4. 6 minus 2 plus 2 is 4. 6 minus 4 is 2, and I can put them in there. And I'm done, because notice you have 2 plus 2 plus 2 is 6 electrons. Now, can you keep a secret? Shh. It's time for a gift from Dr. White. A little gift, but it's a nice gift. Now, when you go to higher level atomic number elements, some of the rules break down, and there are a lot of exceptions. And you could spend the next week or two learning the exceptions. It's not worth it. So it's time for a little gift from me, Dr. White. Remember, it's a secret gift. And that is, on a test, I will only ask you to know how to do electron configuration up to magnesium, atomic number 12. On a test and my final, I'll only ask you to know how to do electron configuration up to 12 magnesium. And that way you don't have to learn all the exceptions. You'll find out later on they're more important things than electron configuration. But it's still important to understand the basis of that. And therefore, that's my gift. You only have to know how to do this. Now, let's do another one. Why don't you do the electron configuration for oxygen? And to help you out, first of all, you've got to figure this out, but I'll let you take 5 seconds, find how many electrons in oxygen. Quick, clock is ticking, tick, tick, tick. That's lame. And the answer is there are 8 electrons. How do you know that? You come over here, oxygen, chemical symbol O, atomic number tells you how many protons and electrons. There's 8. Now, go ahead, you try doing the electron configuration for oxygen. Remember, this material in chapter 9, and I'll get to chapter 5 next, will be on test 2, not test 1 this Thursday. Well, if you got your video on, I can see all of you working on it. And some of you are even done. When you're done, give me a thumbs up. Or smile. If you don't like what you're doing, you can do, nah, don't do that. All right, anybody need more time? Going once, twice? All right, let's do it. All right, now we want to do electron configuration, 4 points each. How do you do it for oxygen? Well, what's the first shell? And the answer is 1. How many subshells in 1? 1. What's the first subshell? It's always lowest energy, S. And the subshell is both a number and a letter. So the first subshell is 1s. How many electrons can we put in there? 2. And I'm going to do that. Now, how many subshells in 1? 1. And it's 1s, 2 electrons. It's full. Now we have to go to next lowest energy subshell, 2. How many subshells in 2? 2. And the first subshell, the lowest energy subshell in 2 is 2s. How many electrons can we put into any s orbital? 2. So I'm going to do that. Now, I filled up 2s, and how many subshells does 2 have? 2. The first one is 2s, and the second one is 2p. How many electrons maximum can I put in any p orbital? 6. How many do I have to go, though? 8 minus 2 plus 2, 4. 8 minus 4 is 4. I could put up to 6, but I only need 4, and I'm done. And that's how you do it. Now, if you go and look at magnesium, which is atomic number 12, this is secret, don't tell anybody. You'll only have to know these right here, how to use them, and also the first 3 shells. How to use. And that's because I'm cutting it off at that. So that's how you do electron configuration, not this week, but next week. I'll go through a problem set for chapter 9. We'll do more of these. And another thing I have to do this week is for my lectures that I have from 12-11 that also cover this, I'll put those what you should be watching. But right now you're probably getting ready for test number 1. So sometime later this week, I'll post that. Now, there's something called orbital diagram, and this shows where the electrons are in each of its orbitals, and numbers, letters, and boxes. See board, for example. Guess what? I'm turning the switch off for orbital diagrams. It won't be on the test number 2 or my final. We've got enough to cover, especially since we're online. Let's see. I see people already doing this stuff. Good. So orbital diagrams, I'm just going to skip. Now, periodic table tells us a lot, and there's certain trends that things increase or decrease when you go across a row called the period. And that's all I'm going to ask. Now, if I had a dial, like on an amplifier that only, or your stereo, that only goes up to 10, I have just turned it up to 20. Again, I stole that from Spinal Tap, the movie. If you haven't seen it, it's a weird movie, interesting, but weird. But anyways, it's a classic if you're in the kind of group who like weird classics. But the next topic is extremely important. And that are the valence electrons. And what are the valence electrons? You should know the valence electrons are the outermost electrons of an element. And they're designated by what's called the group number on top of the column of the periodic table is equal to the number of valence electrons that each element in this column have. Subtle today, you should know this. So you should know that the valence electrons are the outermost electrons. And these are the electrons that are involved in chemical reactions, making new molecules. And that's why I'm not asking you to learn all the rules for the electron configuration for other elements, because valence electrons are more important. Now, valence electrons are the number of the group column in the periodic table. And you see that as a Roman numeral or standard periodic, standard numerical number. And the maximum number of valence electrons any element can have is 8. So the key thing here is look at the top of the periodic table. I'll show you that in a second. Either Roman numeral or standard numeral gives you how many valence electrons. All right, let's do this. Notice I have on top of here in red, before I do this, quick check. Can everybody see the green periodic table? Those of you with black and white monitors, well, it's black and white. I don't know if they even sell those anymore, black and white. All right. I found out a couple of years ago they weren't teaching Roman numerals for a while in grade school. I learned it in grade school. And such as this, what is IV? That's Roman numeral for 4, V is 5, VI 6, VII 7, VII 8. Well, because students hadn't learned this, because they weren't taught it, that's a shame, but that's another story. On top here, the number in red are the important valence electrons. So if I ask you, how many valence electrons does sodium have? You find sodium, Na. Look at the top, 1. It has 1 valence electron. If I ask you, how many valence electrons does hydrogen have? In this case, it's in the same column. It also has 1. Now, if I ask you magnesium, how many valence electrons does magnesium have? And the answer is you look on top, and the number 2, or Roman numeral 2, is 2. Same thing for calcium. All right, I've got to share the fun. How many valence electrons does carbon have? And on a test, remember this was test number 2, I could ask that question, 1 or 2 points each. How many valence electrons does carbon have? Your turn. Time's up. Carbon, chemical symbol is C. Look at the top, number 4, it has 4 valence electrons. All right, let's do another one. How many valence electrons does bromine have? Go. I see somebody's already found it. All right, time's up. Bromine, Br. Look at the top. It's a halogen, but I didn't ask that, but you should know that for test 1. But for test 2, it has 7 valence electrons. I see someone has a question. No? All right, let's do one more. One of my favorite elements on the periodic table, because I used it when I was getting my PhD thesis, is argon. How many valence electrons does argon have? And don't give out the answer, give people time to figure it out. All right, argon, chemical symbol Ar. It's a noble gas. And if you look at the top, since you don't know Roman numerals, a lot of you, see the number 8. And this is a periodic table you will also get for test number 2. And you know argon has 8 valence electrons. So the number on top of the column here in red, and there's red up here too in case it didn't look clear, is the number of valence electrons. And nitrogen has 5, sulfur, like oxygen, has 6 valence electrons. All right, I'm turning the switch off. The size of an atom, which plays a role in many things in our daily life, is called the atomic radius. You know about radius of a circle. And the radius increases when you go down a periodic table and decreases when you go left to right. I'll never ask this on a test, but other classes might. So I'll just mention it briefly, switches off for this slide. Ionization energy, I'll talk more about this later on. That's the energy needed to remove an electron from an atom. It decreases when you go down in a column or group. And when it increases going from left to right. And the element that has the highest ionization energy is fluorine, anion, Fl, or fluorine. And I'll talk about the switches off now. And I'm going to skip this slide. The end, not a lecture, but that's chapter 9. I see a question maybe. All right, no questions, people. All right, let's move on to chapter 5. And now we're getting into the juicy stuff. Let me just do a quick check. Everybody see chapter 5? Thank you. And I've already done the chemical formula. It's shown here, but the chemical formula that I went through earlier today will be on test 1. And I already did this. All right, switches on for test 2. Types of chemical compounds. There are 2 types. One called ionic. The book calls the other type molecular or covalent. More likely I use covalent compounds. So these are the 2 types of chemical compounds. When you look at any compound, salt, water, your hair, that's made up of chemical compounds. It's either ionic or covalent. Now, just in case, and I'll never ask this on a test, but I've used the term, so I really should define it. What's a molecule? A molecule is a group of 2 or more atoms that function as a unit because the atoms are tightly bound together. So when you have 2 or more atoms bound together, we call that a molecule. Right now, you're breathing in molecules of oxygen, nitrogen. I hope you are. Now, what connects or keeps those atoms together in molecules? And we call that a chemical bond. I'll never ask what is a chemical bond, but I'll use the term, and you should know that a chemical bond is the attractive forces that hold atoms together in more complex units we call molecules. So chemical bond is what holds atoms together in what we call molecules. You can't see it, but the water in my water bottle is made up of hydrogen, oxygen, H2O. And what holds the two hydrogens and one oxygen together in this material, the chemical in this bottle, and that's chemical bonds. So if you had X-ray vision, I don't, but you could see that those atoms are being held together. And what holds them together are the chemical bonds in a molecule. Now, there are two types of chemical bonds. Switch is on as high as I can turn it. The first one is ionic bond. The other type of chemical bond is a covalent bond. Two types, and you should know this. And the first one is ionic bond, and the second one is covalent bond. Remember, chapter 5, like chapter 9, will be on test number 2. Hint, know this. What is an ionic bond? The ionic bond is the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. You should know that. You should know this for test 2. And I have results from, you don't have to worry about this part, but what's an ionic bond? It's the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. So the key thing is ionic bond is transfer of one or more electrons, and therefore that causes the ionic bond. And as always, I'll be posting a video for this on YouTube. By the way, Dr. White once again has retained his title as a YouTube star, whatever that means. Now, covalent bond, and again, the results from, you should know, it's the sharing of one or more pairs of electrons between atoms. And usually we're talking about just 2 atoms. Dr. White's being subtle. You should know for test 2, what is a covalent bond? And that results from the sharing of one or more pairs of electrons between atoms. Remember, a pair means 2. So you have pairs of electrons being shared. Now, the difference between ionic, you transfer one or more electrons. Covalent, you share one or more. And the important thing here is pairs of electrons. And you should know that. So ionic, transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Again, the important thing here, transfer one or more electrons from one atom or group of atoms to another atom or group of atom. Again, didn't know this. And the covalent bond is the sharing of one or more pairs, and that's pairs, not single electron, pairs meaning two electrons between atoms. Now, in your book, they have a whole thing about nomenclature. Now, nomenclature is a fancy word meaning name. Switches off for this slide. Now, right before World War I, the countries of the world determined we've got to standardize chemical names. And chemical names are very important. They're used in contracts. They're used in other legal documents like patents. And right after World War I, an organization was set up, again, switches off, which goes by the acronym IUPAC. I'll never ask this on a test. IUPAC, International Union Pure Applied Chemistry. They have their own website. There was actual treaty signed by 138 countries at the time in about 1918, 1920. United States was one of the signatories of that treaty, and they set up the IUPAC organization, and their mission is to be the group or organization that has set up the rules how to name all chemical compounds. Now, it turns out before IUPAC, chemicals had names. We call those common names, and we still use both, but in legal documents, we use IUPAC. And again, it was created about 1920. Official name switches off here. Common names are more widely used for certain things, and IUPAC are too. I know both. I'm going to skip this on ionic compounds. I'm going to skip this also ionic. Polyatomic ions switches back on. They're a group of atoms that have acquired an electrical charge when, which is shared among atoms of a group. So you can have atoms connect together existing as a group that have a charge. We call these polyatomic ions. I'm not going to go through the nomenclature. Now, there are a couple of key ones I'd like you just to be familiar with. And let's look at some of these. There we go. Nitrate and nitrite, NO3 minus, NO2 minus. And these are sodium nitrite and sodium nitrite, nitrate. Those have been used for many years, preservatives of meat. And how many of you have heard, and I don't buy into it, and that's my personal opinion, but how many of you heard over the years certain mothers groups and others said, ooh, sodium nitrite and sodium nitrate in certain foods cause problems in children, like processed meat, bacon, which has a lot, and as a preservative. They've cut down the level, and now even they're selling meat you can buy at the supermarket without preservatives because of the concern. Well, those preservatives are mainly sodium nitrite and sodium nitrate, which have those polyatomic ions. Now, throughout my life, especially when I was younger in our family, when I grew up, important things were salami, corned beef, and pastrami, and bacon. And all those have preservatives, and look what it did to me. Well, maybe you shouldn't eat it. No, I'm just kidding. But some people believe it, and there might be some problems, but like, do they cause cancer and things like that? I don't know, but I keep my level of those down mainly because those are salts, And the doctors told me keep the salt level down in my diet to keep my blood pressure down, which I try and do because I like being alive. Surprise, surprise. Now, another one is by sulfate. We'll talk about this one, Hco3 Bicarbonate. And if we look at a molecule with bicarbonate, which that's a 3. This is the bicarbonate right here. Doesn't look like it, but it is. Eventually I'll get good on this tablet. And sodium bicarbonate is the main ingredient in baking powder. So if you ask, where do we see all these things? These are in our daily life. And we'll learn more about that this semester. And when I say know these names, not really, I've changed since I wrote this slide, but be familiar with them. Just have an understanding that these are things in your daily life. They're polyatomic ions where they have a charge. That's what makes them an ion, but there's more than one atom grouped together, and these are important ones. If I look at the clock, I have to say, it's about time for me to say goodbye. Remember, tomorrow, make sure you've uploaded your lab number 1. Tomorrow, I'll go through lab number 2, and I'll talk a little in the beginning about Labster. And with that, gay and gesund, be healthy. Bye. I'll see you tomorrow. And remember, I have my office hour tonight. I think one of you had a question, which